How do you determine if something, if a decimal is terminating or repeating? Well, to do that, we're going to work backwards. We're going to look at some terminating decimals and look at their fraction equivalents. 4/10 has the same name as its fraction 4/10, as does 37/100 and 419 thousandths. For every terminating decimal, or decimal that stops and does not repeat, we can write it over its place value. The last digit's in the tenths place, so our denominator is 10. The last digit in the hundredths place makes the denominator 100, and so on. This means that all terminating decimals can be written as fractions with a denominator of 10, 100, 1000, and so on. So any power of 10 in the denominator will always terminate. So if we go the other way and I have 7/10, will that terminate? Of course, it's 7/10. What about 19/100? Will that terminate? Yes, it's the same name. So if we have a fraction that we could turn into a number that's over a power of 10, we know that would also terminate. Here are our powers of 10, and I want to look at what they really mean. 10 to the first is just 10, or 2 times 5. 10 to the second is 2 squared times 5 squared. Make a connection between the exponents. 10 to the third, or 1000, is 2 to the third times 5 to the third. That tells us any power of 10 can be written as 2 to that same power times 5 to that same power. This is important because our denominator, if it contains any number of 2's and 5's, we can turn it into a power of 10. If it contains other things, like a 3, 7, or any other prime number other than 2 and 5, it will not be able to make into a terminating decimal unless we cancel it out. For example, if we know, here's a question. If the unit fraction terminates, do all other numerators also terminate for that particular unit fraction? So for example, 1/20th is 0.05. Will all of the 20ths, 2/20ths, 3/20ths, 4/20ths, up to 19/20ths, will they also terminate? The answer to this question is yes. Because all I'm doing is I'm multiplying this decimal, which already terminates, times the numerator, 2, 3, 4, any whole number up through 20. When I multiply a whole number times a decimal, I'm going to end up with another decimal. It won't start repeating just because I have more of them. The other question's a little different. If the unit fraction repeats, do all of the numerators for that fraction also repeat? So let's look at 1/60th. Well, 1/60th repeats. So do 2/60ths, 3/60ths, 4/60ths, do those all repeat? Let's look at the prime factorization for 60. 60's prime factorization is equal to 2 to the second times 3 times 5. That's 4 times 3 is 12 times 5 is 60. In this prime factorization, I have some 2's and 5's, but I also have a 3. And that's a little bit annoying because that's what's making the decimal repeat like this. That 3 does not go into a power of 10 because it's not a 2 or a 5. So if I had the fraction 2/60ths, or 2 over 2 squared times 3 times 5, I can simplify that, get rid of the 2 up here and one of the 2's down here, and I'd have 1 over 6 times 5 is 30. This does not terminate, this repeats. So we haven't gotten rid of what's really important that's messing up our terminating decimal, which is the 3. However, if I looked at 3/60ths, or 3 over 2 to the second times 3 times 5, in this case that 3 does cancel out with our denominator, leaving us with 1 over 4 times 5 is 20. 1/20th, which is the same as 3/60ths, is 0.05. 20 goes into 100 5 times, so what I'm technically doing here is I'm multiplying both of these by 5, or a form of 1. That gives me 5 out of 100. 5/100ths is 0.05. This is true for all decimals that we can make from fractions. If our denominators go into powers of 10, then we know the decimal will terminate. So if our denominator was 40, which is the same as 2 to the third times 5, I can multiply this by 2 more 5s. If I multiply the numerator and denominator by 5 over 5, that's a form of 1. My denominator is now 2 to the third times 5 to the third, which is the same as 1,000. My numerator doesn't matter, whatever number that is, even if it's a prime number like 17. I would just do 17 times 25 to get my numerator. First times 5 squared here. 425 over 1,000 is equal to 0.425, or 425 thousandths. It terminates because my denominator has only 2's and 5's. Any other denominator will not work unless the stuff that's making it repeat, as in this 3, gets canceled out with its numerator.